how can the same metal loss flaw produce a different assessment MAWP under API 510 and API 579 Part 5? Under the API 510 approach, the thickness used for the future MAWP calculation is based on the actual thickness, minus 2 times the projected future corrosion loss. Under API 579-1, ASME FFS-1 Part 5, the future corroded thickness is based on the actual thickness, minus 1 projected future corrosion loss. Same component, same flaw, so why the difference? The answer goes beyond the equations. It has a lot to do with how much is known about the actual flaw before its pressure retaining capability is evaluated. Under API 510, there may be a reliable minimum measured thickness, but that value does not necessarily provide detailed characterization of the localized metal loss geometry. It tells us how thin the wall is at that measured location, but not necessarily the complete depth, length, width, and thickness distribution across the damaged region. One way of understanding the additional projected corrosion deduction is therefore in the context of uncertainty surrounding the actual governing condition of the flaw. The thickness used for the future MAWP calculation is T equals T actual minus 2 times the projected future corrosion loss. That additional deduction reduces the thickness credited in the pressure calculation. And because MAWP is directly influenced by the wall thickness used in the pressure equation, a lower value of T ultimately produces a lower projected MAWP. API 579 Part 5 approaches the same flaw differently. The damaged region is characterized using detailed thickness measurements. A UT grid is developed, and from that inspection data, the critical thickness profile, or CTP, is established. The assessment now has more than a single minimum thickness. It has information about the depth, length, and actual thickness distribution across the damaged region. This matters because the structural effect of localized metal loss depends on more than its deepest point. A relatively short local thin area can benefit from stress redistribution through the surrounding thicker material. As the flaw becomes longer, that ability to redistribute the load reduces. The future corroded thickness is established as T equals T actual minus the projected future corrosion loss. But this does not mean API 579 simply gives the damaged component more credit. The structural effect of the actual flaw is evaluated separately through the fitness for service assessment. And this is the important distinction. If you want more practical integrity discussions that go beyond quoting API equations and explain the engineering reasoning behind them, subscribe to Integrity Insight now. Subscribe and turn on notifications so you don't miss the next fitness for service breakdown. Now back to the comparison. The real difference is not simply 2 times the projected corrosion loss versus 1. There is more behind those numbers. With API 510, the localized flaw may not be characterized to the same level as a detailed fitness for service assessment, and an additional thickness margin is reflected in the future MAWP calculation. With API 579 Part 5, more information is developed about the actual damage. The flaw is mapped, the critical thickness profile is established, and the influence of the actual flaw geometry on remaining structural strength is evaluated separately. So when the same flaw produces different assessment MAWPs, do not look only at the 2 equations. Look at how the damaged condition was characterized, how the future thickness was established, and how the structural effect of the flaw was accounted for. Same component, same flaw, same projected corrosion, but a different assessment approach. Ultimately, both are trying to answer the same integrity question. How much pressure can the remaining components safely retain as corrosion progresses?